Okay, let's continue on with graphing quadratic functions. Okay, first of all, there's something that we should know about the base function. We need to examine a value here for the input between 0 and 1. So I've picked x equals a half. And these values between 0 and 1 are special because when you square a half, you're taking half of a half, which is a quarter. So you're actually getting a smaller value. So after you square a proper fraction, you get an even smaller value. That's the only time this happens. Otherwise, whatever our input is, we multiply it by itself, so it just seems to get larger and larger and larger. So we have this swooping upwards here. But between 0 and 1, we have this sort of rounded part of the parabola. So for example, here I'm putting in a value halfway between 0 and 1. So then there's my x value of a half, and I should only be a quarter the way up to that 0.1 because a half squared is a quarter. So all our drawings of parabolas should have a little bit of a rounded area near the vertex. Okay, so now that we fully understand our base function, one suggested way of graphing it is to look at vertical and horizontal shifts of the base function. So here, when someone presents me with an equation like this, I notice, hey, look, here's the squared function going on, and then just some numbers being added or subtracted. So I recognize this as, this is a change in my x, so this is a horizontal shift. And then I memorize some sort of result, like it's always opposite to the sign shown. So by that, I mean that if it's -3, that implies that the shift is a +3. Okay, and then here, since this happens after everything has been done, it's just being sort of directly added on to create the y. This is a vertical shift, and it's the same. It's not the opposite. It's up 2 or +2. Okay, so you can go ahead and memorize that whatever's being added or subtracted from the x represents a horizontal shift, and that we have to move the opposite way as what's indicated by the sign, and that whatever is just tagged on at the very end after you've done everything else is going to be a vertical shift, and it's going to be in the same direction as the sign indicates. So from there, we can go over here and we can say, okay, the base function that I'm graphing is x squared, but I'm going to take it and I'm going to shift it to the right 3. So what I do is I go 1, 2, 3, and then I draw a new, what I like to call the x-axis. And then I go up 2, 1, 2, and I draw my new y-axis. These aren't x and y-axes, but you can see that the base function exists here with its vertex right on the corner of the x and the y-axes. So now my new vertex is going to be over here. So you can see that it's moved from the point 0, 0, 3 to the right and 2 up. And now, because there's been no change to the shape, I can just reproduce this shape, which is 1 over from the vertex, I'm up 1. 2 over from the vertex, I'm up 4. So this point isn't actually 4, since the vertex was 2 up to start with. This would be at a height of 6, and it's not actually at an x value of 2, since we were shifted over by 3. So this point would be 5, 6, but I'm getting it starting at the vertex and going over 2 and up 4, because that is my base shape of my function. So then I draw like this, and then I recognize that, hey, these parabolas, these quadratic functions, have a nice symmetry. So left 1 is up 1, and left 2 is up 4, and left 3, oh hey, this is nice. It actually gives me my y-intercept. So left 3 is up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. And since the vertex was up 2 to start with, this is at 11. So there's the idea, and this generalizes. You can know the shape of any base function, and then you can just recreate it at your new vertex, which you think about as whatever, the opposite of whatever's happening to the x, and that would be horizontal, and then the number that's tagged on after everything else has been completed, that represents a vertical shift. Okay, so this is one approach, shifts of the base function. The other approach is that you just learn to read a mathematical equation. So let's rewrite it again here. It says y is equal to, and then it's got a bracket, and then it's got a value x minus 3, and whatever that is going to be squared, and then I'm going to add 2 onto it. So listening to the equation is kind of like doing this table of values, but instead of actually picking values and subbing them in and seeing what happens to them, we look for extreme generalizations. So we acknowledge that we have worked with this squaring function before. So we have investigated. So we understand that anytime you square something, it will become positive. So let's go over here. Since we don't actually want to fill this in, this is kind of tedious. We want to sort of fill it in through intelligent observations. So what I actually think here is that y is equal to something, some number, which I'm going to get by subtracting 3 from whatever x it is I picked. So if I pick x is 10, this is going to be 7. If I pick x is 5, this is going to be 2. If I pick x is minus 1, this is going to be minus 4. So this is going to be some value right here, and then I'm going to square it, including its sign, right? There's a big bracket around here. So it's going to be something squared, and then plus 2. So then I start thinking to myself, well, what happens when I square something? So let's look at this whole part here. What do we know about that? Well, it's always going to be positive. It's always greater than or equal to 2. So already I know that all of my outputs will be greater than or equal to 2. So this will be the lowest point on my graph. So y equals 2 will be my lowest point. Oh, sorry, I should have first acknowledged that the square is always greater than or equal to 0. And then y is always greater than or equal to 2 because it's this value, which at its lowest is 0 plus 2. So if the lowest this can ever be is 0, then the lowest y can ever be is 2. So it's always going to be bigger or equal to 2, so that means that the lowest point is actually at 2. Now, I go back and look a little bit closer at this something, and I ask myself the question, well, when will this be 0? This will be 0 when x equals 3. So then I now know that my lowest point is 2, and it happens when x equals 3. So I go 1, 2, 3 to my x coordinate, and then I go 1, 2, up 2, and I say, hey, here's the lowest point on my graph. Well, since it's a squared function, I know that's its vertex. I know it has symmetry on either side of that. There's no multiplication factor here, so it retains the base shape that I'm comfortable with. If I go over from the vertex 1, I'll be up 1.